right. What we're going to do now is we're going to talk about quadratic functions. We've done most of what we're going after today. We've done most of it before in one form or another, but now we're going to bring everything together. By a quadratic, what I mean is function f of x equals ax squared plus bx plus c, and a can't be 0 because it's not a quadratic. It would be just a plain old linear function. Things we want to know about these functions. Well, for one thing, the graph is always a parabola. Could be like that. Could be like that. Could be like this. It can either be up or down. The shape of the parabola can vary. It can be very steep. It can go up very quickly. Or it could be very shallow. What determines these properties is the a value. Specifically, if a is greater than 0, then it's a parabola up. Kind of got a smile there, right? It's a little devilish. If a is less than 0, then it's parabola down. If I think of like a equal 1 is like a standard parabola. Nothing really standard about it, but I actually plot some points here. It's going to go through f of x equals x squared, where a is 1. It's going to go through 0. It's going to go through 1, 1. And it's going to go through negative 1, 1. If a is greater than 1, well, let's think about this here. If a is greater than 1, we're multiplying this first term by some value, which is going to transform it upwards. So if a is greater than 1, it's kind of it's going to go up faster. It's going to be narrow, or even like this. I mean, you know, out here it has a value, but it's just off the blackboard somewhere. If a is less than 1, I guess clearly greater than 0, but less than 1, then it's going to be shallower. Now we're going to talk about, you know, how to graph, you know, these different shapes in a second. But for now, you know, we just want to have a feel for, you know, just by looking at A, we can already tell a lot about the parabola. The other two values, B and C, are only going to affect one thing. They're going to affect where the parabola is on the coordinate plane. All the points will shift, right, depending upon B and C. So what we really want to know is, you know, where is the vertex, right? This is going to be at some point HK, typically used. So we want to be able to find HK. Okay, how do we do that? Now you have really there are other ways to do this, but we're going to go over completing the square. You really have no choice at this point. You have to learn how to do this. So let's take a look at this example here. F of x equals 2x squared minus 12x plus 13. And we don't want to try and complete the square on 2x squared. We want to take that out. So 2x squared minus 6x plus 13 over 2. All right. What do I do to the, this is now the b value, a1. What do I do to this value to find out what I need to complete the square? I don't think this is going to help you like learn this or do it, but I think it's useful to think about this in a certain way. This is the way the Greeks would think of this problem. They didn't know how to handle negatives, so just thankfully that's a positive. They would draw something like this. Let's just make this x squared plus 6x per second. And they would say, all right, here we have a square. Do I make that come out right? So I draw it carefully. Here I have a square. One of the sides has length x, part of it has length x, and the other part has some unknown value. And the other side also is broken up into x. So what is this? Well, let's take a look. Let's just give it some value. Give it a value of p. Right? And this is p. So I look at the whole thing, and what do I have? I have x squared plus p times x plus p times x plus, now this is p squared. So I have x squared plus 2px plus p squared. Well, 2p, that's my b value, my 6. So p has to be 3, and p squared has to be 9. This is 3, this is 3. So this is what they mean by completing the square, figuring out what this 9 is here, right? We know that this here, p is just b over 2. And so p squared is just going to be b squared over 4. Okay, so that's just another way to look at what we're doing here, completing the square. Of course, this diagram doesn't work if you have a negative here, but the process works the same. Okay. So what do we do now? So this is 2x squared minus 6x. 6 divided by 2 is 3. Squared is 9. So we're going to add 9. But of course, we have to subtract what we just added. We have to subtract 9, but it's 9 times 2, which is minus 18. All right. Probably would have been better if I just kind of left 13 out. Right.
Over 2.
It was over 2 because it was inside here. When I took it out, though, I multiplied it by 2. Thank you. Okay, so this becomes 2. Now we have x minus 3 squared. 13 minus 8 is minus 5. And now I just want to do one more thing. I actually want to bring the 5 over to this side. Since we're drawing a graph on an x-y axis, I'm just going to, instead of say f of x, I'm going to say y. Okay, what was the purpose of this? The purpose was to find out where the vertex moved when I added the bx and the c. Well, in this form, you can just read it off as a transformation, right? The same way we do with a circle. My x is just going to be 3. I'm saying x minus 3, so if I plug in 3, I get 0. But here, what do I plug in to make y 0? It's negative 5. So for this particular, just use my graph here. For this particular parabola, I want to go 1, 2, 3, and then down 5. 1, 2, 3, 4, 5. So now I have my vertex. Here's my a value is 2. Right? That tells me it's going to go up quicker. So one thing I could do is I could just plug in, 1 on either side, right? So 1 squared is 1, but times 2 is going to be here. And of course it's symmetric. Did I do that right? 2 is about here. Better with graph paper, of course. Another thing you can do sometimes is you can find the roots of the equation. The roots of the equation are going to tell me where it's going to cross the x-axis. For this parabola, that will work because it crosses the x-axis. It might not, right? You might have a parabola up here. Its roots are complex, and this isn't going to work. But so how would we do this? Well, we could try and factor this. That would be painful. I don't think it's going to work anyway. So now we're back to quadratic formula. Well, plus or minus the square root of 12 squared, 144, minus 4 times 13 times 2. 4 times 13, 4, 52, 104, all over 2a, all over 4. Well, plus or minus the square root of 40 over 4, or 3 plus or minus, let's work on the square root of 40 over 4 first. That's 2 times the square root of 10 over 4. I think that's about all we're going to squeeze out of it. So it's 3 plus or minus square root of 10 over 2. Okay, what's the square root of 10? It's about 3 point something. It's about 1.5. I'm just doing a very rough graph here. So 3, approximately 1.5. So it'll be 1.5 or 4.5. So 1.5 or 2, 3, 4.5. Okay, so I can get 2 more points on my graph that way, and then I can try and draw a lovely curve through them. Okay, so that's how we would graph a parabola. And I'm afraid that's all we have time for today. workshop on Friday.